Hello everybody, welcome into another lesson. So today we are going to solve simple radical equations. And those types of equations are honestly like what you see here. You're going to have the variable inside of the square root set equal to a number, such as the square root of x equals 3. But we want to solve for x, right? So there's an easy way to get rid of that square root. You just square the square root of x. So let's go ahead, we'll take the square root of x to the second power. That's going to equal also the right side squared, because what you do to one side you got to do to the other. So now you'll have the square root of x squared equal to 3 squared, which means you would get x equal to 9. Now, with square root equations, you have to be cautious, especially into some of the equations we're going to have today. It might look like there's multiple solutions, but what could happen is you could end up getting a negative number inside your square root, which would make this undefined because there's no real solution, or you could end up getting a false statement. So what you need to do is check. We'll put 9 in for where the square root of x is. So we'll set the square root of 9 equal to 3, and it turns out it does equal 3. So you have a true statement, 3 equals 3, so the solution to this equation is going to be x equals 9. That does work out. All right. We have the square root of y is equal to 14. So we've been given the square root of y equals 14. Well, what we need to do now is take that square root of y, raise that to the second power, but we also got to take that 14 on the right, raise that to the second power. Well, square root of y to the second power just becomes y. 14 to the second power, that's 196. So it looks like we're done, but we have to make sure we're done. So we're going to put in 196 for the square root of y, and then we'll set that equal to 14, and yes, square root of 196 is 14. 14 does equal 14. You have a true statement, so yes, the solution to this equation is y equals 196. Alright, that wasn't so bad. Alright, a little bit different here. We have the square root of 2x is equal to 4. So we've been given the square root of 2x equals 4. Well, still the same procedure. You're going to put the square on both sides, square both sides, so take the square root of 2x, that quantity, to the second power, but that's going to equal 4 to the second power, which would mean the square root of 2x, that quantity squared, just becomes 2x. That's going to equal 4 to the second power, which is 16. Now you have 2x equals 16, which means x would equal 8. But before we go any further, we need to make sure that this solution works. If I put in the square root of 2 times 8, set that equal to 4, let's see, square root of 2 times 8 is the same as the square root of 16. And then square root of 16 is 4. 4 equals 4. You got a true statement, so yes. The answer is x equals 8 for this equation. Right now, it doesn't seem like we got to check much. We could probably get away with it, but when we get into the square root of quadratic equations, that's where things take an interesting turn. Alright, how about this one? Square root of 8x equals 2/5. So we have the square root of 8x equals 2/5. Okay. So what we need to do now, again, square both sides. So take that square root of 8x, you'll raise that to the second power, but you also got to take that 2/5, raise that to the second power, which square root of 8x raised to the second power, that's just 8x. That's going to equal 2/5 to the second power. That would be 4/25, which would have to mean that x would happen to equal 4 all over 8 times 25, which would happen to mean that it equals 1 all over 2 times 25, which is 1 all over 50. But yes, it looks like we have our solution, 1 over 50, but is it really? Well, let's go ahead and put that answer into our square root. So take the square root of 8 times 1/50. We will see if that's equal to 2/5. Well, let's see. 8 times 1/50, that would reduce into 4 over 25. That'd be the square root of 4 over 25. Would that equal 2/5? Well, the square root of 4/25 actually is 2/5. We have 2/5 equal to 2/5, so yes, we have a true statement. So the answer for this equation is going to be x equals 1/50. You would in fact get 1/50 for your answer. Alright, a little bit different here. We have the square root of m minus 3 equals 1. So now we have something we're subtracting from the square root of m minus 3. Well, all we have to do to get that square root of m by itself is add 3 to both sides, right? So if we do that, you'll get the square root of m would be equal to 4. Now we got something we can solve. Square root of m equals 4. You just square both sides, you'll get m is equal to 16. Well, now we need to actually check the solution. Is that an actual solution? So put in the square root of 16 for where you see m. So you'll get square root of 16 minus 3, is it equal to 1? Well, square root of 16 is 4 minus 3 equals 1. 4 minus 3 is 1. 1 equals 1, so we have a true statement. So yes, the answer for m is it's going to equal 16. All right, let's see. We have the square root of z minus 2 equals 7. So we've been given the square root of z minus 2 equals 7. Well, we want to get that square root of z by itself, so you just add 2 to both sides. If you do that, you'll get the square root of z is equal to 9, which means you have to square both sides to just get z. If you do that, you'll get z is equal to 81. But is 81 the actual solution? Let's see here. If I take the square root of 81 minus 2, is that equal to 7? Well, square root of 81 is 9, minus 2, is that equal to 7? Yes, 9 minus 2 does equal 7, so 7 equals 7. We have a true statement. So the answer we're looking for here is z is equal to 81. So yeah, that was pretty simple too. Just getting the square root by itself and then going for the solution. All right. How about, let's see, this time it's different. We have the square root of x over 2 equal to 3. So we've been given the square root of x over 2 equals 3. Well, we still need to square both sides. If we do that, you'll end up getting x over 2 is equal to 9. Which then we need to multiply both sides by 2 to get that x by itself. If you do that, you'll get x equals 18. But is 18 truly the solution? Well, let's put that in the square root where we see the x value. So you'll have the square root of 18 all over 2. Is that equal to 3? Well, 18 over 2, that's 9. So now you have the square root of 9 equals 3. Square root of 9 is 3. So 3 equals 3. You have a true statement. So yes, x equals 18. That's exactly what you would get, is x equals 18. Alright, a little bit different here. This time we have the square root of x plus 1. Everything there is inside the square root equal to 3. So we have the square root of x plus 1 equal to 3. Well, we still need to square both sides to get that x plus 1 by itself, right? So if we do that, you'll get x plus 1 on the left side. That'll be equal to, on the right, 3 to the second power is 9. So now you're going to get x plus 1 is equal to 9, which means x would equal 8. But we have to do the second part and determine here, is 8 the actual solution? So take your square root of 8 plus 1, set that equal to 3. Well, 8 plus 1 is 9, so you have the square root of 9 equal to 3. Square root of 9 is 3. 3 equals 3. We have a true statement. So yes, x equals 8 would actually be the solution to this equation. So as you see, these really aren't terribly bad. These aren't bad at all. Alright, what about... Let's see, similar ones. So we have the square root of m plus 5 equals 1. So this is going to be a good one here. This is going to be a very good one. Alright, so we still need to square both sides to get m plus 5 by itself, right? To get rid of that square root. So if we do that, you'll have m plus 5 is equal to 1 to the second power, that's still 1. So now you have m plus 5 equals 1, which means you just need to subtract 5 from both sides. If you do that, you get m equals negative 4. Would negative 4 be allowed in the square root? Some of you are going to say no, because that's a negative number. I'm going to tell you why it's allowed. Because if we put negative 4 in for m, you'll have the square root of negative 4 plus 5 would be equal to 1. Well, negative 4 plus 5 is 1. Square root of 1 equal to 1, which square root of 1 is 1. 1 equals 1. So yes, we can use m equals negative 4 as a solution. As long as it doesn't make the entire result inside of the square root or the radicand negative, you're good. It doesn't mean you can't have a negative number somewhere in here, but it can't make the entire m plus 5 negative, if that makes sense. Alright. Let's see, we have 5 times the square root of 2x equal to 20. So we've been given 5 times the square root of 2x equals 20. Well, we want to get that square root of 2x by itself, right? So divide both sides by 5. If you do that, you'll just get the square root of 2x is equal to 4, which is now much better to work with. Now we want to get 2x by itself, so we have to square both sides. If we do that, you'll get 2x is equal to 16, which now we want to solve for x. That would just give you x equals 8. Well, we've already checked this one. We had a very similar problem. If we put in 8, so yes, let's put in 8 for the square root anyway and just check it. So we'll take 5 times the square root of 2 times 8, see if that's equal to 20. Well, then we have 5 times the square root of 16, which is equal to 20. 5 times the square root of 16 turns into 5 times 4. See if that's equal to 20. 5 times 4 does equal 20. 20 equals 20. So yes, x equals 8 would actually be your solution to this equation. You would end up getting x equals 8. So with square root equations, you still have to remember to check, and I'm going to demonstrate why here in a few minutes, but alright, let's see. 2 times the square root of 3x equals 5. Well, I can tell you now the solution's not going to be very pretty, but we're going to do this one anyway. So 2 times the square root of 3x equals 5. Well, we want to get that square root of 3x by itself, right? So you got to divide both sides by 2. If you do that, you'll get the square root of 3x is equal to 5 halves. Alright, well, we want to just get 3x by itself and get rid of the square root, so we have to square both sides. If we do that, we have 3x is equal to 25 over 4, which now we have to divide both sides by 3 in order to get x by itself. If we do that, we get x equals 25 twelfths. But is 25 twelfths really the solution? Well, let's do our test here. Let's put it in for where we see this, the x and the square root. So let's take 2 times the square root of 3 times 25 twelfths. Set that equal to 5. So then you'll have 2 times the square root of, let's see, 3 and 12. Let's see, 3 is a factor of 12, so this would end up reducing to 25 fourths. Set that equal to 5. So you have 2 times the square root of 25 fourths equal to 5, which would give you 2 times 5 halves, because that's the square root of 25 fourths is 5 halves. Set that equal to 5. 2 times 5 halves is 5. 5 equals 5. We have a true statement. So yes, it's true that x, the solution for x in this case, is x equals 25 twelfths. Okay. Here's a good one. We have the square root of 5m minus 5, all that in the square root, plus 6 is equal to 7. So we have the square root of the quantity of 5m minus 5, all that plus 6 equal to 7. Well, first thing we want to do is get that square root of 5m minus 5 by itself, right? So we got to subtract 6 from both sides. So if we do that, you'll get the square root of 5m minus 5. That'll be set equal to 1, which now we have something we can work with. We want to get rid of the square root on the left side and simply get 5m minus 5, so we have to square both sides. If we do that, you'll get 5m minus 5 would be equal to 1 to the second power, which is just 1. Okay. Well, now we need to get 5m by itself, so we have to add 5 to both sides. If we do that, you'll get 5m equals 6. And then you would end up needing to solve for m, so divide by 5, you'll get m equals 6/5. But is 6/5 really going to be the solution? Let's find out. Let's go over here, put this into our original equation. Take the square root of 5 times 6/5 minus 5, all that, plus 6, set that equal to 7. Well, let's see, in the square root, 5 times 6/5, that's going to give you the square root of 6, then minus 5. All that plus 6, set that equal to 7. Square root of 6 minus 5 turns into the square root of 1. Then you have plus 6 equal to 7. Well, square root of 1 is 1. This turns into 1 plus 6 equals 7. 1 plus 6 is 7. 7 equals 7. You have a true statement. So yes, the answer in this particular case is m would equal 6/5 by the time you do all the checking and all the math. M equals 6/5. All right. I think we'll do one more like it. Yeah, actually, let's move on here. A slightly different version. So, let's see. We have the square root of 2a squared minus 5 equals 11. Well, upon first glance, it's almost going to look like you're going to have two solutions because you have a quadratic inside the square root. So let's go ahead and square both sides to get that 2a squared minus 5 out of the square root. If we do that, you'll get 2a squared minus 5 is equal to 11 squared, which is 121. Well, next goal is to get that 2a squared by itself. So add 5 to both sides. You'll end up getting 2a squared equals 126, which then, if we divide both sides by 2, you'll end up getting a squared equals 63. Well, we have to go back now and put this into, we have to solve for a, which means you got, whenever you solve for a quadratic variable, remember you take the square root of the variable side, which would actually end up being a, but it's plus and minus the square root of the number on the right hand side. So a equals plus or minus the square root of 63, which this can reduce further. A equals plus or minus the square root of 9 times the square root of 7, which means that a is equal to plus or minus 3 times the square root of 7. Well, here's the thing though. If I take this answer, because we have two solutions here. I have both plus and minus 3 times the square root of 7. If I take either of those solutions and put them into the square root, I should still get a positive number. Why is that? Why would that be? Because if I square a negative number, it's still going to come out positive. So, in other words, these solutions will check out. I'm going to save us a little bit of trouble here and tell you that I mentally put these in, and they do check out. If 11 would equal 11, you would have a true statement. But remember, whenever you take the negative solution and put that in, raise it to the second power, you get a positive result. So a is equal to both plus and minus 3 times the square root of 7. Now, let's see here. We have the square root of x squared plus 6x is equal to 4. So this looks like another quadratic equation, and it temporarily will turn into one. So we have x squared plus 6x equals 4. Well, we need to get x squared by 6x out of the radical, out of the square root, right? So we square both sides, and if we do that, you'll end up getting x squared plus 6x is equal to the 4 squared, which is 16. So now you have x squared plus 6x equals 16. Okay, well, we basically now we're going to treat this like a quadratic equation. You're going to subtract 16 from both sides to get 0 on the right. If you do that, you'll get x squared plus 6x minus 16 is equal to 0. Alright, that's good. Well, now we need to factor x squared plus 6x minus 16. Well, that's going to be simply x plus 8 times x minus 2. Set that equal to 0, so you would get, x plus 8, that quantity, times x minus 2, which means x would equal negative 8, and then x would also equal 2. This is where I say, if you don't check in linear ones, if you just have a linear variable in your radicand, that's okay. But when you have quadratic variables in your radicand, this is where you really need to check. Okay, so let's go ahead here. Let's put in negative 8 into the equation here. So I'll take the square root of negative 8 squared plus 6 times negative 8. Square root of all that, that's going to equal the square root of 64 minus 48. Well, 64 minus 48, that's 16, so I have the square root of 16, which equals 4. Well, 4 equals 4, so actually x equals negative 8 checks out. I was thinking it was possible we were going to get a negative number in the square root, which would have thrown out the solution. There will be times with these types of equations you may end up having to throw out one or both of your solutions because you get undefined numbers in your square root. Or you may even get a positive number, but it doesn't equal the right-hand side. So that's why it's important to check. Now let's go over here. We'll take the square root of 2 squared plus 6 times 2, which is going to equal the square root of 4 plus 12, which equals the square root of 16, which also equals 4. 4 equals 4, so in this case, both of these solutions check out. X would equal negative 8 and positive 2. Both solutions actually checked out, but it doesn't always end up that way. Let's go on to the next one here. We have the square root of a squared plus 3a equals 2. So we have another quadratic in the square root. We have a squared plus 3a equals 2. We want to get rid of that radical from the left-hand side, so we square both sides. If we do that, you'll get a squared plus 3a equals 4. Which now we treat this as a quadratic equation. You need to subtract 4 from both sides to get 0 on the right. If you do that, you get a squared plus 3a minus 4 is equal to 0. Well, let's go ahead and factor this. You would end up getting a plus 4 times the quantity of a minus 1. So you have a plus 4 times a minus 1 equal to 0, which then we just solve for these. A would equal negative 4, and then a would equal positive 1. But do both of these solutions check out? Let's make sure. Let's go over here to the left. I'll work with negative 4. So we'll take the square root of negative 4 squared plus 3 times negative 4, which means you're going to get the square root of 16 minus 12, which means you get the square root of 4, which means you get 2. 2 equals 2, so actually a equals negative 4 checks out. Now how about 1? We'll take the square root of 1 squared plus 3 times 1. That's going to equal the square root of 1 plus 3, which also equals the square root of 4, which equals 2. And 2 equals 2, so yes, a equals 1 is also your solution. So your two solutions are negative 4 and positive 1. But again, it doesn't always work like that. Alright, let's see. We have the square root of 15x squared minus 12x is equal to 9x. Well, it would be true we want to get rid of that radical on the left-hand side, so let's square both sides. You would end up getting 15x squared minus 12x. That's going to equal 9x squared. That's 81x squared. So now we have a quadratic on both sides. This time I'm going to make 0 be on the left. It's going to be easier that way. If I go ahead and subtract everything from the left-hand side, I'll get 0 on the left-hand side. 81x squared minus 15, that's going to be 65x squared plus, no, if I subtract, no, I'd actually have to add the 12 to the left-hand side, so I would get 65x squared plus 12x on the right-hand side. Now let's switch this around. I would get 65x squared plus 12x equal to 0, which now I can factor out a common x. I would get x times 65x plus 12 equal to 0, which means I would get x equals 0 as one of my solutions. But how about, let's see, so 65x would equal negative 12. That means x would equal negative 12/65. But is negative 12/65 a viable solution? I can tell you without a doubt, if you put 0 into these equations, you'll get a true statement. You'll end up getting 0 equals 0. So we are for sure taking 0 home with us as a solution. How about the negative 12/25? Well, I mean that negative 12/65. Here's the thing. Let's forget about the left side for a second. Just put in negative 12/65 on the right. You have a positive 9 times a negative number. You're going to get a negative answer on the right, aren't you? The square root of a number just the square root with no signs in front of it, if you just see the plain square root of a number, it's always going to be positive. So right away, one of the things is violated about square roots. So negative 12/65 actually would not be a viable solution. So x equals 0 is actually your only solution. So this is why it is so important to check your work when doing square root equations, because there will be times you'll have to throw out entire solutions. I'm glad I actually have one. I could give you an example of that happening. Because up till now, you've probably all been thinking, okay, you're doing too much work, you're checking everything. Well, there was a real reason for that. And I have the last problem here, then we're done for the night. So we have the square root of 20y squared minus 13y. That's going to be equal to 5y. Alright, so the square root of 20y squared minus 13y, all that's equal to 5y. Well, we want to get rid of that radical on the left, don't we? So you square both sides. If you do that, you'll end up getting 20y squared minus 13y is equal to, if you take 5y to the second power, you'll end up getting 25y squared. So now we have a quadratic on both sides. Well, I'm going to do the same thing as the last equation. I'm going to make 0 on the left-hand side to start with. So we'll subtract the 20y squared and add 13y to both sides. If we do that, you subtract 20y squared from the right, you'll end up getting 5y squared. And then that negative 13y, you have to add 13y to both sides. You would actually end up getting 5y squared plus 13y. So now let's rewrite this here. We'll move sides. You'll have 5y squared plus 13y equals 0, which means you can factor out a common y. So you get y times 5y plus 13 is equal to 0. So you'll get y equals 0 as one of your solutions. Then you see you'll have 5y equals negative 13, which means y equals negative 13/5. Well, so we have two solutions so far. We have y equals 0 and y equals negative 13/5. Well, looking at 0, you're going to get 0 equals 0 again. So yes, without a doubt, y equals 0 is definitely a viable solution. But is negative 13/5 a viable solution? Well, you don't even have to worry about the left-hand side for a moment. Look at your right-hand side. You'll have 5 times a negative number. If you do the multiplication, you would end up getting negative 13. Well, the square root of a number can never be negative. It can only be positive. So right away, we discard y equals negative 13/5. And again, your only solution to this is y equals 0. So solving these square root equations are actually pretty simple. The biggest thing people get themselves into trouble with, I mean, the linear ones, they're pretty easy. The ones we did towards the beginning, the linear ones, yeah, those are basic algebra, like almost pre-algebra level. Those are nothing to worry about. But when you get into these quadratic ones, it can look like you have two solutions, but and where people get into trouble is they don't check their work with both solutions. And that's how they end up getting answers wrong, because you could end up getting a false statement and not have a viable solution. So that's it for this lesson. Now, we have 5 more lessons left in Algebra 1, and the last 5 lessons will be focused again on quadratic equations. So it's true we've done quadratic equations by various types of factoring, but there are some other methods too that I'm going to teach you. So yeah, 5 more lessons of Algebra 1, then we're on to geometry. So I hope everyone has a good night. Take care.